Right. The topic that we will focus is today. Today we will on decision tree. Decision tree is a method that allow you to model pattern and in input, and then use them to segment or divide the data into parts. Those parts would be associated with the target. And the target that we talk about would be classes. That means decision tree can be applied to classes, but it can also be applied to the problem like regression. Like you can associate the pattern in the input and then associate them with the mean of the group, and that you will have the regression problem, right? The transform everything to regression. So that means the decision tree can be applied to either classification, like in logistic regression, or in regression, like in linear regression. And today we will look at this technique. It is a quite powerful technique. And even for today, I'm still using this technique once in a while. When you want to perform segmentation of the data, you have a set of data, you have the target, you want to find a group that associate with the target. You can use this decision tree to help you to do segmentation automatically. If you want to perform estimation of values, like I work with the logistic company once, and they want to estimate the lead time, the time it takes for traveling or from when the order comes, and then you want to fulfill the order. That times can be vary depending on the locations. I can use this decision tree technique to estimate this lead time, right? The time that this happens, even though there aren't any previous transaction occur between places before. By performing prediction based on the existing data, you can find patterns, associations, and then use those to estimate the lead time. Right? Decision tree can be used to perform classification, which you obviously see in this lecture. All right. So we will begin the lecture here, and then there will be some demonstrations later on in these lectures. And I also post the lab that you have to create a classification model using the bank data that we have been working on throughout this semester. Oops, I think this is distracting. Let me close it down first. Okay, so let's begin. I will post the data set that we will use here in this lecture later on. We'll start with the lecture theoretical part. The skill, the technical part, I'll post it during the break, and then you can download them during the break. Okay. Okay. Ingครับ, do you have the HR dataset?
HR dataset เหรอครับ
Yes.
ไม่รู้เอาไว้ไหนหรอก
All right. Never mind. I'll post it during the break. You can download them. You can download it, and then.
Is it the same as human resource dataset on Kaggle?
Yes, I think. yeah. I suppose so. You can post the link into the group.
Okay, post the link to the chat and to the group.
Sure. I suppose so. I can see if it is. Let me check. Let me check it first. Yes. Oh no. No. No, this is not the one. But this one is interesting. I will download it for later use. But no, it is not. It is not. You cannot delete the link. Yeah, I'll just post this. No, it is not the one. I will post the link into the Facebook.
And there is another one with the number of project, average monthly hour, and time spent company.
The one Well, I'll post it anyway. Never mind. Never mind. I'll post the actual data, not the link, into the group later on during the break.
Because the one I just feel like I've seen it before. Predict who's gonna left the.
Yeah. That one. Yeah, I think it's that one.
Okay, I will send you through private.
Okay, send.
You check first.
That would be better. This data is actually come from IBM, and I'll be using to demonstrate ability to do the HR work. Left salary satisfaction. No, this is not the one that I use here. Never mind. All these are good, but I will keep them. But I will keep them for using in later session, but probably not the one that I have prepared here. Thank you. Let's begin anyway. We can then we can take a look at the theoretical aspects of decision tree. If you have questions during the lecture, feel free to send us the private chat or the chat. Then I can answer it once I finish each of the slide. And I know you are comfortable with this kind of interactions because of the nature in that you have watched a lot of live through YouTube to the channels, I guess. But yeah, feel free to drop in with the questions time to time. I will take a look at that. Let's begin. So what we are going to take a look is a technique called decision tree, right? You can think of decision tree as a way that allow you to perform segmentation, right? The term segmentation refers to a process that you have a group of individuals, then you want to divide a group of individuals into segments, into smaller groups by means of looking at some variables, and that variable would be the thing that you are interested in. Like you might want to separate customers into customers who are likely to purchase, who are not likely to purchase, right? You might want to separate customers to be customers who have high value, right? Those who would have been purchasing a lot of things and with low value. You can separate, you might want to separate devices into the device that might have problems and the device that still work fine. So the process of segmentation allow you to divide the groups, or divide the individual into the groups of quantity of interest. It depends on the quantity of interest, the thing that you want to predict, the thing that you want to divide the group to. And for decision tree, the technique itself, it allows you to predict. Predicting means that you have the current data and you have another data set. You want to use this data set, the current data set, to predict tomorrow, right? That's predictive model. It can be done by means of using previous or historical data sets. For example, if I want to predict what would happen tomorrow in terms of the stock price, in terms of the customer coming in, or in terms of customer purchase, I can take a look at the previous data from the last month and then create a time lag. Like this would be tomorrow. And I use the data from today and yesterday and predicting tomorrow. And by doing it this way, scanning something like this through the past historical data, I can create a model that associate current pattern, today pattern, with tomorrow patterns, right? So that is called predictive modeling. You can use this type of technique to perform segmentation, right? Dividing individual into group that likely to perform and group that are not likely to perform, group that likely to or the event that likely to happen or not happen. So the main question of the supervised segmentation, supervised means that we have label, we have these future labels to associate with the past. the problems, the questions would turn into how can you divide the individuals into segments? How can you divide populations into groups with respect to the quantity of interest that you have? This quantity of interest would be the thing that you want to predict or the thing that you want to estimate. One example would be each day I can create a crawler, a program that download Twitter's or Facebook message automatically, and I have a bunch of them here. And to have people reading through this one by one would be a laborious task. One thing that can be done is that you can sampling out a smaller set, and then from this smaller set, you ask human to annotate them, which one is positive, which one is negative, and then create the decision tree of supervised segmentation that would automatically perform separation of that message into positive and negative group, just like this one, into positive and a positive, negative, and neutral. Right? That can be done automatically. So you can use if you have the data in that format, you can apply the technique to perform a lot of cool stuff like estimating sentiments from text, classifier, a lot of things here. You can perform prediction, like you can estimate which customer would likely to leave the company. Like if you work for telco, this would be called churn. If you work for the bank, you might want to find customers who would not pay, who would likely to not fulfilling the contract when you when that customers had got the loan, right? Find potential customer who likely to write off, and those customers would not be given the loan potentially. Or you can may want to find a web page that contains some questionable contents like fake news. That can be done using this classification model. Okay, I can create a model as well, like to avoid the event that you get F by finding people who likely to get F based on all likely to fail in my class beforehand, and based on the previous transaction, which I don't have access right now, and then your record in the previous years in terms of the file. And then I can create a classification model to estimate who likely to fail my class. And then I might create a special group, a special content for those groups so that they can avoid the futures that might happen. That would be cool. Problem is, if I am to do that, I will need to ask the university to grant me a lot of access to the data set, which I try to get just the list of student record, and I have to fill like 3 forms sent through the bureaucratic process of the universities. And let's keep that idea afloat. One day it might happen if we have data warehouse. We have data warehouse and have proper data governance policies to create this type of projects. It would be cool. Have a lot of useful stuff here, right? Or you can use the predictive model like this to perform targeting, right? Target customer or consumers who would likely to respond to the offer, right? Or find a web page that would fit the query that you have. Right. Or a lot of other things that I have been working on that fit in this. For example, for banks, we worked for the government housing bank last year. We created a model for them. This model would predict which customer would refinance the loan, right? The loan contracts that that have with the bank. If the bank know who will refinance the loan beforehand, they can make an offer so that the customer will still stay with the bank. So we created that model for them, and then they will run this model automatically through the years, and then they will know which customer would likely to finance, to refinance. Refinance means leaving the changing from one banks to like another banks to get like lower interest rate. The bank usually try to avoid this because they would lose the customers who pay the interest to the loan. Right. So that's what we did. We created a classification model to do the job. Back then, maybe like 6 years ago, I supervised one of your seniors, fourth year students, to participate in the Microsoft Imagine Cup and the software contest, the national software contest, and they won the first prize. And they were the winner in that year, and they created founded the company in Sierra to do this social analytics, right? Social network analytics. So that work in that work, they have to create this sentiment analysis model that predict the sentiment of the text that they have. Like if you say you are not happy with the company, right, to online channel, right, the system will crawl the data, particularly if you post them in Twitter, because those are public data, and then we'll analyze the sentiment of the text so that, okay, you are not happy with this brand. We can create brand monitoring, monitor whether people talk badly about the brand or not. And then they can create, the company can create a type of response to respond to the problems quickly. You might have seen this in Pantip.com, in various places, that the company react to the comments quite quickly, even comments from their competitors. Right? So these are the potential application of classification model. Right? The data set that are required to do the classification model would be in terms of the tabular format like this one. You will need to have at least, you need to have this target column. This target column would be the class column. You need to have the classifier either to be yes or no, to be belonging to class A, B, C, depending on the job here. So that is one requirement, that you need one column to be the target. You need and also you need to have a number of columns here to be the attributes. So the data would be similar to when you work with regression model, like logistic regression model. Okay. The process of creating machine learning classification model. Right. You may have seen this decision tree in news lately. Like, okay, government use decision tree to do the AI. Actually, it's not that bad, especially in the case that you don't have too much data and you want to perform just segmentation. Decision tree is not like you manually configure the tree. You train the tree to learn from examples. You have data, train the tree to learn from the data, and it gives you segmentation. The good thing about this is give you segments. All the techniques like neural networks, support vector machine, more complicated techniques would not give you segments. Sometimes you want segments. You want a set of criteria that you can apply to a larger scale, a larger scope. Yeah, but the technique itself is not that that effective. I mean, in terms of the accuracy, it's not that good, but it's more generalizable here. So for the classification model, this includes logistic regression and or even linear regression for the regression model. It works when you create a model. The process of creating a model requires the first step would be training the model. You need to train the models, and then once you got the trained model, you can perform prediction or estimation using the model. Okay, training the model requires a pair of inputs and labels. That means for each row, you need to have a set of input and a label. Okay, and this input will be processed, and the meaningful features will be extracted. And then features and label will be used to train the machine learning algorithm. And the results of this would be the models that is trained based on the data. And we would have input coming in, pass through the same feature extraction as the above, and then make prediction to get the predicted result. This is the process of creating machine learning, particularly the so-called supervised learning. Right. The so-called supervised learning. Right. Supervised learning is, I would say, is a class of methods that, or is a more of a conceptual approach that you can create models based on the patterns in the data associating with the labels. Okay, so this is one of the technique, right? Supervised learning in supervised learning area. There are other areas as well, like unsupervised learning, and that is the clustering technique. And semi-supervised learning, which you train the model with a portion of data based, and also using unsupervised technique together with this. But we will focus here on the supervised learning. Okay. Right. Applications of classification can be arranged in the various way. You can use classification to perform churn prediction. The word churn here means leaving companies, or actually with today's subscription models, churn would indicate that customer would leave the contract. Right? You can see that nowadays software and a lot of not just software services maintain a list of customers, and once the customers leave the company, or once the customer leave the service, the customers would just use an alternative, right? An alternative service, use the alternative service to fulfill the job. Like if you use Grab, like Grab food consistently, once you kind of want to switch, maybe you switch to another provider, right? Lineman, maybe, I don't know. And once you switch, maybe you would not come back. You will just switch to the other one. Or if you are the using a credit card of one company, when you use it a lot, I mean, if you have multiple credit cards, if you decided to switch to another one, you may just switch and then use that as the main credit card. So churn prediction right now is a very important model that almost all businesses want to build. They need this into maintaining the customers. In targeted marketing, classification allows the business to create a model to predict which customer would respond to the advertisement, to the offer. So this is also important in terms of sales. You can use classification to assess the risk, to predict the risk of problem of the risk of device would fail, the risk that customer would not pay. So this is a risk prediction, or failure prediction, to predict in terms of the manufacturer. You might want to predict whether the model to predict whether the batch from the data, which batch would fail from the QC or not. Or perform sentiment analysis, or even do a more AI-oriented model, like creating a speech recognition, which would recognize the speech. Well, speech recognition means that you have speech passing through model, and then it will convert to text. It recognizes the speech. Also, for this one, you have image, and then passing through model. Then it can do a lot of things like classify the image into object type and authors, right? So that means classification model can be used to ranging from you create a base business models or creating an advanced AI in robotics industry to so that it would react to human automatic like naturally. So yeah, and recently is one of the basic technique that allow you to create such model quite efficiently. The data that are required for creating a model will be like this one. You need to have first labels, and secondly, you need to have attributes. Right? The labels and the attributes data. Attribute data are the thing that might happen in the past. For the labels, it can be the thing that you want to estimate or the future label that would happen. Okay. Usually these would be historical record. The data are drawn from maybe previous years, past records, so that you can associate, like suppose I would draw the timeline here. For this, you might have like this one event occur here in that at that position, that the thing that you want to predict. And you might want to use like maybe 3 months of data to predict the event, okay? And that would allow you to associate the 3 months to the event which occur in the futures, creating a predictive modeling. And if you want to do this, this would have to come from a larger set of data, maybe extracting them from like 3 years worth of data, because you want to create a sliding window of 3 months. Right, creating a sliding window of 3 months, and then extract that data set out and resulting in a single view of data set, right, that contains each event. Each row would be each event that occurring, maybe each customer, and the column will be the attributes, right? The most important thing here, well, the way that I put it here is like would answer the question of how you can create a data set. But the crucial question here is not how, is this one, whether the label is correct or not, right? You need to have correct label, right? The correct label would answer the objective. Like if you want, one example would be in 2 years ago, I worked with the Metro MEA, right? MEA is the electricity authority of in Bangkok and the central region. I work with them, and then initially they want to build social mining, social analytics. I don't know why they want to do that. So I went to talk to them to ask why do they want to build that model. For some data scientists, they may just receive order and then just do that. But you should keep in mind on why do you need on the question to properly answer the actual need that are there. So I discussed with them why do they want to build the social listening. It turns out that they actually did not want to do that. They just read from some articles and think that would answer their problems. The real need is that some of their customers did not pay the bills. They did not pay the bill, and that's the problem. They want to know who will not pay the bills beforehand. So they thought that if they know the feeling of the customers, that would help them. But instead, I suggested that the problem itself can be framed into classification model, predictive model, to predict the liable who will not pay. Right? So the problem shifts from creating a large social network analytics into building a focused model to perform classification. Okay, so determining the liable is very crucial here. You need to think about the real need and then extract that out from the data set and from the discussion and from the other aspects. I think you have more practice on this in your later class. There will be a class on business intelligence. You probably have to think about this a lot. Okay, for this session. All right. Okay, so here the data for the attribute data, you need to have these data types. First is the demographics data types. Demographic data types indicate is the data types that explain the the properties of the unit of analysis. It depends on the unit of analysis. This would be one-to-one relationship. It would be one-to-one relationships. That is, one people often has just one value, or you can think of it as the static attribute. It will be attribute that no, it's not actually the static attribute. Like age, you know, it's not static. So what I would say would be like one-to-one would be fine. Right? Think about them as one-to-one relationship. One individual unit of analysis would have just one value. For transactional data, this is the data that associate, would you have the one-to-many relationship. One unit of analysis would have multiple transactional data. For example, transactional data like playing games. When you play games, when you download games, you play game multiple times, right? Each of those times would create transaction, and that is the transactional data. So when you have you use the mobile phone, right? You have one mobile phone numbers for that one. When you make a call, you would have like for the last month, you would probably make multiple calls. So each of those calls will be transaction. Okay, so transactional data is the data that involved with yourself and the business. Interaction data is the data that occur when unit of analysis here interact with one another or interact with the business. In the term, well, interact with the business, but not in the main functional business area. Like if you call your mobile phone provider to complain, that's interaction data. But if you make a call to your friends, that's transaction data, the transaction that you make. Why is that? Because in interaction data, your intention is to create interaction, is to engage. Right? Usually occur from like email, a chat that you chat with the company, or email chat that you chat with your coworker. You can create transaction data as well. Or it can be something like your interaction in terms of the social networks. Okay. The last one is the behavioral data. Behavioral data is the data that indicate the behavior of the unit of analysis. For example, it can indicate that the need, the desire, the need. How can you indicate the need? Right? If bank monitor your saving money, the saving accounts or the accounts in the banks, they might see the reduction in the money, right? If you are like good customers and usually used to have like a high level of incomes coming into the company might want to offer the some types of the financial service to you if they see that you will need that, right? Or at the end of the years, usually that would be the seasons to buy the to buy investments like LTF, RMF, and right now SSF to make tax deduction. Company might estimate that you would need to buy that tax deduction at that time and then make offer. like we can use credit card to buy the tax deduction and other things, right? So those are potentially variables that relate to the behavior that can be used here, right? So you need various types of data set, and because there will be multiples, there will be multiple attributes that can be used. The model, especially decision tree, need to find the one that have information and then select that one to do the job, okay? This is called the informative attributes. Informative attributes is an attribute that contains the, well, attributes like some properties, data, the variables. Informative attribute will be attributes that provide information, right? Provide information about something. This would be about the target that you want to predict. If the attributes contain better information, good information, then uncertainty will be reduced, right? You would feel more comfortable. So that means selecting informative attributes would provide a way to select subset of data. And that subset of data can be used to do classification here. Okay, for example, this is just an example of attributes or uncertainty attribute, uncertainty in the attribute. Suppose that your friend tells you that the class today is canceled, right? Your friend tell you that, and me telling you that the class is canceled. Which one contains more information that reduce the uncertainty about the class being canceled, right? So you can see that, suppose that your friend tells you, you probably need to find, is it true? You probably need to find a second opinion, asking another friend, is it true? Or coming from what? Coming from my post or coming from which source, right? Or you may believe your friend, that's another matter. But you can see that informative attributes, or if your friends, these persons, would not be joking around. This person would always provide informative attribute. That means it's trustworthy. Right? So that is the things, right? The value of information would be differ from the from the better information, right? It would reduce that information. Also refer to the source as well. Will reduce uncertainty more. Right. Another example of this would be U.S. politics. U.S. politics, like if Donald Trump says something, comparing to the statement from the administration, from U.S. administration, mean the government. Usually, Donald Trump would be way less than. But it's funny because president statement is weighted less than the document. This is like funny because in the past, usually the words coming from the leaders of that country, the US, would be like a lot of would be trustworthy to all around the world. But right now, it's like, well, have to check. This is strange times, definitely. Okay, now which attribute to be used? Right, to be used to perform segmentation. Segmentation means dividing, which attribute to be used. How do we know, right? We want to judge which one give the best information and use them to do ranking or automatic selection. Select it to perform segmentation, but which one is the best one? Should it be occupations, whether you are using age, using resident, using income, which one would be the best one? Let's take a look at this example. This is an example of, let's say, the write-off. Write-off indicate not paying, even that maybe these individuals would not pay the loan, the rent, or whatever. Right? And then we want to predict which will write off. Now we have the labels here on above the head. And the attributes contains three. We have now three attributes: head shape, body color. And for this one, head shape can be two types: square or circular, right? Square or circular. Body shape can be rectangular or oval. Body colors can be black and white. and white, and the target variable can be yes and no. Okay. Now we want to know which one of these will allow us to make prediction about the target variable the best. Okay, we want to find which attribute would be best to segment, that it would segment the peoples into groups, and those groups would allow us to distinguish write-off from non-write-off. The way to do that is to measure purity of the group. The purity of the group refers to the homogeneity, right? That the groups contain just one value. If the group contains just one value, it means that the group contains doesn't have the mixture of label in it, and that's good in terms of segmentation. You want to kind of segment the group that have one label out and have like less mixture of the group in mixture of label in the group. If the members have different targets in the group, that means it's would be mixture, and then you would not be comfortable to label the labels to the group. For example, comparing this, suppose that you perform segmentation and you finally got this subgroup G1 and G2. G1 contains 4 individuals. These 4 individuals all have class yes. G2 contains 4 individuals as well, and in these individuals contain mixture of class yes and class no. So if you want to conclude for G1, which class would you conclude that G1 belong to, yes or no? Right? You would conclude that this is the yes group because all the individuals have yes label. But for G2, this would be difficult because you have 50% of G1, 50% of yes, and 50% of no. Right? So the purity refer to the mixture, right? The homogeneous, right, of the group. How to measure that? You have already learned that in physics class, I suppose, about the mixture of elements, about the, right, or in chemistry. You can see that in disciplines in engineering and science, they all sometimes share the concepts, share the mathematics together. Okay, so that's measurements that you may have learned in the physics, in thermodynamics. That's called entropy. Entropy is the measurements of disorder. Okay, you can use this concept to measure the mixture, the impurity of the segments. For example, if the segments are mixed up between the labels, then it would have high entropy. Entropy can be measured by using the Gibbs entropy equation in thermodynamics. Gibbs entropy equations have forms like this one. This is proportion of being to class 1. So when I talk about this, it means that we would have, we may have the data set like this one. And then you have one label, maybe Y. This Y can be yes, maybe no, no, yes, no, whatever. So each row contains labels. And you want to find, for example, one column here, column X, X1, and column X1, we have A, B, B, B. You might want to use this to divide the class, like X1 equal A, or X1 equal B, and then you have 2 groups here. In these 2 groups, they may have different proportion of Y, like it's going to be Y, no, no, Y, no, whatever. So you can use the X to divide into Y into groups. And in each group, you can calculate the proportion. Or even for this one, you can calculate the proportion. P1 and P2, and P3 if you have 3 classes. P1 would be the proportion of label 1. P2 proportion of label 2. For now, we have proportion of Y and proportion of N, right? So we have 2 classes. And so this entropy would have like P1 log 2 of P1, P2 of log 2 of P2. So this formula would have highest value at which P, okay? There's an association here that P1 plus P2 must equal to 1 because these are probabilities of the class, right? That means the combination of probability of the two have to equal 1. Like if you combine probability of not buying with buying, right? The two are complement with one another, then you get value of 1. So from this equation, what value of P1 would result in highest entropy? Okay, can you guess? Make a guess to chat. What value of P1 would give highest entropy? Any guess here? Right, we got response here. 1, 1, 1, 1. No, actually no. It's 0.5. Why is that? Because entropy will be highest if they are impure. And that indicates in this equation. If you take a look at this equation, suppose this is log 2, right? If you have value of 1, what does it mean? It means that P1 will be 1. And then log P1, log of 1, what is the value of log 1? Log 1 is 0, right? And if P1 is 1, that means P2 would be 0. And 0 times whatever, log P2 would be actually minus infinity, approaching minus infinity. But 0 multiply anything would be 0. That means now you have the value of entropy. If P1 equal 1, then entropy would be 0. Not the highest, but this value would be highest. If we say P1 is 1 over 2, right? P1 is 1 over 2, or I would write it as 2 to the minus 1 here. For simple, 2 to the minus 1, 2 to the minus 1, 1 over 2. If it's 1 over 2, what would happen? When you take a log of exponent, the exponential part here would be putting down, right? That means minus 1 would combine with the minus to be plus. And then log 2 of 2 would be 1. That means you have like 1 over 2 plus 1 over 2, which equal 1. Okay, so if P1 is 1 over 2, in this case, you would have entropy equal 1. Right? So that means the more mixed labels are, the higher the value of entropy. Okay. Right, so it works like this one. This is the proportion of P1 in the group. The more mixture it has, the higher the value becomes. And if you have like probability of 0 or 1 for P plus here, you would have entropy of 0. That means the groups are pure. And with this homogeneity, you can definitely say that it would be minus class or plus class. Okay. Remember that we have 2 classes in this example. That means when you have all the plus here, the probability of being class of the class plus would be 1. Right? While if you have minus here, probability of class minus would be 1. Probability of class plus would be 0. Right? So now let's take a look at how to make calculation using the entropy formula. So if we have like a set of 10 people, and 7 would be write off, 3 would be non-write off, 3 write off, 7 non-write off, then the calculation of entropy comes this way, that you can take P write off 7 over 10, 0.7, and write off 3 over 10.3, and then plug them into the entropy equations, and then make a calculation here, then get 0.88. Okay. Having just entropy is only like part of the calculation. In order to define or identify variables that would reduce the uncertainty the best, you would need to find a way that represent the reduction in entropy. And there is a method that uh, is used to do that. Like this is our information gain. Information gain would calculate the gain of information by calculating the decrease in entropy. So the basic idea is very simple. You just take entropy of the parent before division, and then minus the entropy that you gain that you got from children after division, and then you have this IG, the information gain. Okay, so the basic concept is to find entropy of the parent, and this is actually the expected value of entropy of children. You learned this in the statistics class. Like expected value is calculated from the proportion, the probability multiplied by the value, right? The random variable. So for this one would be the entropy. You get proportion multiplied by entropy, proportion of C1 and C2. C1 and C2 would be the group C1 and group C2 after division. Right? That would be example next. Let's take a look at them. Okay. Let's take a look at this example step by step. Okay. Initially, here we have an entire population. This entire population contains 16 of dot and 14 of stars. Right now, if we calculate proportion of dot and star, that would be here 0.53 and 0.47. Okay, for the probability of dot and probability of star. Now, from this one, we can calculate entropy, right, using the entropy equations. Minus P dot time log 2 of P dot plus P star time log 2 of P star. And this P dot would be like 0.53. And for this one, all right? And that's the log of P, right? Multiply together and can make calculation, you get value of 0.99, right? You can expect that based on this. Based on the mixture, you can see that it's about half. When it's about half, the entropy will be highest. So we have like value of 0.99, very impure. Now, suppose we use this criterion, the criterion of balance. Balance not less than 50K or balance more than or equal to 50K. Use this criteria to divide the data into two groups. We got the first group. This group contains 13, and this group contains 17 of the points of the data points. And among these 13 points, we have just one being star, and among the 17 points, we have 4 to be dot. Okay, so now let's consider the proportion, this value individually. So if we take a look at this first, then you see that we can calculate entropy from them. From this point, you have P dot equal 12 over 13, and P star is 1 over 13, right? And then you get the probability out. And from this probability, you can highlight here, right? 0.92 and 0.08 is used there, and also log of 0.92 and log of 0.08 is calculated there. And then we got this entropy from when balance less than 50K. And for the other one, the other segment here on the right side, doing the same thing, we calculate the proportion. Calculate the proportion here. I've got values of 0.24 and 0.76. Plug this value into the equation, and then you get balance more than 50K, right? The entropy for the balance more than 50K equal these two values. Now you can see that I use another, right, these two values. You can see that these are the entropy of the left side and the right side. Now, if we were to calculate, the information gain, right? We calculate the information gain. Information gain is calculated by taking the entropy of parents and then minus subtract out with the entropy of children. Entropy of children come from the probability of each child and multiply them with the values of entropy. Okay, that's why we have this point 0.43. How do we calculate 0.43 here? Anyone knowing this? Can you give me some idea? How does it comes to 0.43? We can see that 0.39 come from entropy of the balance less than 50K. 0.79 come from this. Right, correct. This is 13/30. This one is 17/30. The probability or the proportion of that class after division. Okay, so combining them, we get the reduction, the information gain of 0.37. Right, 0.37 means there are certain reduction, but the usage itself is not like this one. It's not just we have this 0.37, that's it. We need to use this value in comparison with another variable, right? We focus on which variable is the best one for making division here. Okay, balance give you 0.37. Let's take a look at the next variable. Okay, now if we use residence to make division, okay, and we get, let's say, calculate everything, we get information gain equal 0.13. Okay, balance is 0.37. Okay, balance you get 0.37, residence you get 0.13. Which one would gain you more information? Residence or balance? Which one? Balance, right? Balance has higher information gain. That means balance would give you more information than residence. Residence give you less information, less informative than balance. If you have to choose one variable, and that one variable would separate, would be used to just saying which person would belong to which class, you would choose a balance because balance can give you more information than residence. Okay, now the idea now is to find not just one variable, but a set of variable as well as the way that it would form to create this tree. This is the tree that is called decision tree. In decision tree, it would allow you to classify the data into, so in decision tree, I like the trees, other trees, contains two types of nodes. The first are interior nodes in orange here, and the seconds are terminal nodes in blue. Okay, terminal nodes would contain segments, would contain individual data points, and the interior nodes would contain attributes that you want to test, you want to use them to divide into classes. Okay, and this is decision tree. Suppose that we create this decision tree and we can make prediction from this decision tree. Like suppose we have another person coming in, we don't know whether this person would be right off or not right off. We can use decision tree to make judgment, like 115,000. This is balance, 40, age, and no, the employment. We can start from the root node and decide which class this person should belong to. Right? From the first one, you have the employee yes and no. Claudio has no as employment, so we go down here to balance. And then determine whether balance is less than 50K or more than 50K. Now, if it's more than 50K, right, 115, go down to age here. Now, at the age here, we have the age of 40 for Claudio. That means we need to go down to this path, right? And then we arrive here at the leaf node, and this would conclude that Claudio would be not right off loop, right? So this is the way to use decision tree. But once you have it, but how to create this? Because from previous example, what we have only just like one level. We can just now have one level, but how to do it in iteration? Now let's take a look at, so in order to do that, we need to follow through this algorithm to do the tree induction, creating the tree out. Using the divide and conquer strategy, right? How to do that? We will start with the whole data set. Start with the whole data set. From this whole data set, we will apply variable to select which how to divide the data set, and then we will divide the set into part. Right. So if I were to draw it more illustratively, I would create like something like this one. Right. Divide it. Then I got to part. I'll keep doing that, like dividing this. And I have this. Right. And then keep doing that. Think about this as like a part of data set that you have. Not actual, not actual graphical like dividing the paper, but well, it's more of the same. Like so the idea is to like you have a large set of data set, then you want to make division. So starting with the whole data set, you apply the variable selection to the data set, and then divide them into subgroup, and then recursively repeat number two a number of times. Repeat number of times until you reach the criteria to stop. And that's the idea of this decision tree reduction. Let's try that. Take a look at an example. It would explain this a lot. Okay, starting from this one. Okay, we have the data set look like this. Now, can you tell me which one gives the best information? Right? In order to determine which one gives the best information, what you need to do here is to determine the information gain, okay, information gain of each of these attributes, right? So we will, for this class, I will not compute or make calculation, or maybe I have to do that. Let's do that. So, okay, let's start with head shape. Head shape, if we were to use head shape to make segmentation, it would be divided into square group and circular group, right? So what we need would be the proportion between yes and no. Okay, for square head shape, what is the proportion of square head shape no to yes? You have 1 no, 2, 3, 4, right? 4 of no, and 1 yes, 2 yes, 3 yes, 4 yes, 5 yes. So that would be 4 to 5. Okay. And for circular head shape, obviously you see that is the proportion of 1 to 2, right? What is information gain for this one? What do we need to do first? Right, we need to calculate the entropy of the parent. Right, entropy of the parents here. That means we need to find proportion here first. How many no and yes we have? 1 no, 2 no, 3 no, 4 no, 5 no. And how many yes? 1, 2, 3, 4, 5, 6, 7. Okay, so the entropy, no, it's not entropy 5 to 7. It's 5 to 7. Entropy would be minus, right? P of no. P of no would be 5 over 12 and log 2 of 5 over 12 plus 7 over 12 log 2 of 7 over 12. What is the value of entropy? Can you tell me here? Okay. Entropy is 0.98. Let me create a function that I use. So I'm actually creating a function in R right now. Just use in this example. I'll share that later on. Right, and for if we use head shape, then we will have this square 4 over 5. So the value of entropy for this would be entropy 4 over 5. Be point. So this would be 0.72 plus one would be 1 over 2. Oh no, so 1 over 3. Oh no, sorry. It's 4 over 9. Point 99 and 1 over 2, 1 over 3. 0.91. This times the proportion, which is 9 over how many? 12, right? This is 3 over 12. Right, this is the entropy, expected entropy of child. And then you get like 0.98 minus this to get Ig. Right. So this is how it is calculated. Just calculate entropy of each and then subtract it out, you get information gain. And the value here, well, you can calculate it later. But well, for this class to move on quickly, I will just take a look at the proportion. You can just take a look at proportion and make a guess on which one would give you the best division, which one would reduce the data the best. So if after separation, the groups contains more homogeneous groups than the others, then that would mean the better segmentation, right? So now let's take a look at the next one, head shape. If you use head shape to make separation, to make division, you would take a look at this, body shape, body shape. For rectangular body shape, you have 1 yes, 2 yes. Let's count no first. You would have 1 no, just 1 no, and 1, 2, 3, 4, 5 yes. So this would be 1 to 5. Why for oval? For oval, you would have 1 no, 2, 3, 4 no. 4 no, and how many yes? 1 yes, 2 yes. So oval will be 4 to 2. You can obviously see that using body shape give you better separation between yes and no, right? For rectangular, you have 1 no, 5 yes. For oval, you have 4 no, 2 yes. So obviously, this would have IG lower than, IG for body shape would lower than H shape if you calculate this, okay? You can practice by yourself, make calculation later on to see if it's true. For body color, now we have black and white. If we have gray or black, this would be 1 to 1. If this is 1 to 1, this would be 4 to 6, right? So obviously, body color is not a good choice as well. Okay, so that means the best one would be body shape. If we use body shape to make separations, then we could separate these individuals into more pure, group, better group for classification. Okay, so the best one is body shape. Now we use body shape to make a segmentation. We can segment them into rectangular bodies and oval bodies, okay? Because we know body shape has highest information gain, okay? Now let's work on and then we need to apply the same step to the subgroups, right? For the oval body, which attributes should we choose, right? Now we have 2 choices remaining. Body, we have head shape and body color. Which one? Which one should be used for separation and why? Right. Let's evaluate each of these. Using head shape, can you use head shape to separate yes from no? Right. Use head shape would get you perfect result. Right. Circular give you yes. Rectangle give you no. Right. So that means for head shape will be best for oval body. Right. Oval bodies, if you use head shape, then you can separate yes and no into 2 groups. For the other one, for the rectangular body, we can use either head shape or body color, but let's use body color for the sake of having different variables so that you can see in the tree. But actually, you can use the same or you can use the similar one, the different one, but it doesn't matter, all right? Which one that give you the best result is okay. Right, so this one, in this example, is use the body color to separation. Then from these 3 steps, we would now get decision tree. Okay, our decision tree would looks like this one. So first we use body shape, and then from the body shape we separate them into 2 parts. For each of these, we use body color and head shape, and then separate them into finally this. So we would have this as the interior node. And we have this as the leaf node. Right. The leaf nodes contains the segments. Interior nodes contain the variables that we use to make segmentation. Right. So this is how decision tree is working. It's done. Okay. We will take a break here for we'll take a break here for say 10 minutes. right? We'll take a break for 10 minutes. Then after the break, we will take a look at how can we create decision tree using R. And I will also introduce the concepts of holdout. Holdout is a concept that you hold part of the data for training, and then you use another part for testing, right? Let's take a break here. Right? During the break, I'll upload. Well, I'll just upload it now, right? You have questions about the theoretical part of decision tree, feel free to put it into the chat in the groups, or afterward, if you are currently reviewing this through the video, feel free to post the question into the either the comments in YouTube, the comments in the Facebook group. It should be fine, any of that, right? Okay, let's take 10. We'll come back with the lab on 11:05. I'm loading it first. Okay, let's turn out to the question now. We have the first question. According from entropy formula, how do we know which base lock to be used, or is it always base 2? The original proposal of Shannon in information theory proposed that it should be base 2, based on the work about data communications, because communicating in bit would require the base of 2. In the use of this technique in classification, usually we have binary base, right? So that's why I use base 2 here. But it actually doesn't matter, because you can always convert the log base to auto base, right? So that would mean the value would be different. The value would be lower if you use auto base, but still the main use is to make comparative, make comparison between multiple features, multiple attributes, and that would not affect. Using different log base would not affect that, because as you can see, the thing that you will get is to get different values, just that. But comparing between high and low value between two features still would go still to the same trends, given that you use consistent log base. So use log 2 and stick with log 2, right? And that should be fine. The next question is, can we roughly choose highest IG by using entropy without calculation? Yes, you can. You can using rough estimations like what I did that in the examples. But if you write a code, you cannot make rough estimation. With code, you need to make explicit calculation using code, right? So yeah, that's the things. Okay, but yeah, you can choose rough estimation like I did that. Like if we ask, well, if we ask, you have to read instruction in the exam. If we ask you to calculate or explain in detail, using rough estimation would not be a good idea, right? You would want to make explicit calculation in that. Okay. All right, let's move on. Okay, now I'm going to explain and doing this step by step in R. So I can actually share the screen, and that might be better so that we can follow both the slide and R at the same time. Or let me check, do I have any others? Yeah, I will switch between R and this from time to time. Let's start looking at the demonstration here. Right. So first, you need to import the data. I did not put the code to import data here. So let's switch to R. Right, I'm importing the data in. So I should have HR employee attrition. This should be fine. All right, got the data in. And next would be to, let me share this instead. Sharing screen. Right. So we will select, we remove these columns out because they are unnecessary to be used here. So, okay, let me explain the data first. We have the first column, age. This is the data set about employee attrition. Attrition is an event that the employee leaves the company, right? So age would indicate the age of employee at that time. Attrition, yes or no. Business travel, travel rarely, travel frequently. The daily rate, this indicate the rate of money contained in daily. Department, distance from home, education, the education level. This has to be transformed into factor. All everything as ordinal should be fine. High or low education level. Education field, employee count. This is the count 1 throughout this. We should remove this out. Although the algorithm will remove it automatically anyway later on, because this will not give you any information at all. Employee number, the code should remove it out. Environmental status, gender, the rate again, and job involvement, job level. This comes like how involved to the job and the level of the job. The job role, job satisfaction, whether that individuals are satisfied with the job or not. Marital status, monthly income, monthly rate that this person got, company that this person has worked before this, whether this person over 18 or not. This is only why. So actually, the first step you should do it here is to explore the data set. Once you explore the data set, you will know that this column is not important and you can remove them out. I'll skip those steps because I already know that they are not important because while loop here is only one. And overtime, work overtime or not, percent salary hike, got like more salary in the past, few weeks or few years. What are the performance ratings? Whether this person satisfied with the relationship. Standard hours, which are all 80, so should be removed. And stock option is the option that this individual would get stock in the company as like bonus or as compensation. And total working years so far, training time last year, whether this person has trained in training in the company. The company usually conduct training, right? Or might send you to train with authors. Like I went to I created workshop for companies to do this type of stuff a lot in terms of training. And others like the years at the company, years at the current role, years in the last promotions, from this position, years as current manager. So these are the variables that need to be used, and we remove some of them out. Right? We remove this employee count, employee numbers over 18 and standard hours. Right. Check if it's all right. Suppose those columns are not here because I don't see any static column already. I will assign this to HR data. One. All right, now I got the HR data one, right? So the next is the introduction here. Okay, you can see that by using this, you kind of not seeing this because it's obscure. The view. Let me make a share to this and move it here. Right. So this is called holdout technique. Right? Holdout is a way that you can separate the data into training set and test set. Okay. That can be done by the method of sampling. Right? By randomly sample the data set, you can divide them into two parts. So I will, so whole out would separate the training set out of the test set. So you would have a part to be training set and another part as test set. How to do that in R? Okay, you can do that by first you can sample the index. That index can be the index of test or index of train. Once you get the index, and then you can use this index to subset the data. One would be the test set, right? Minus would mean that this would remove the index belonging to, or the row belonging to this index out. And this would remove, it would select only the test index out. Okay, so I will do this here. Okay, so first I'll set seed. Set seed is used to just set that seed of the random function in RNC. You know that, right? When you set seed, when you get the same random number, right? Do this in order just to, so that even though we run this on a different computer, we get the same result. You get the same result every time you run. Okay. If different, I think if different computer will get the same result. Not really sure, but yeah. Test index come from this. You can try running this first. Well, if you run this, you need to rerun the set seed again. Right. Sample of, let's use a simple one first. If you get sample of 10 and then get 3 of them, then you get results 10, 11, 10, 1, 8, 1, 5, 4. So you get the number from 1 to 10 out. Just 3 of them. Okay, this can be extended to like 15 of them. Oh no, this is a sampling without replacement. So you cannot get 15, you can get 8. Right? So this is sample. So how do we create samples for the data set that we have? You can do that. Okay, and if you run set seed first and then run this, set seed first and run this, you get the same result. Okay, so I can sample it from n row. N row would give the number of row that we have, right? N row of HR data 1. This would give you 1,470. So I would just use this one as the max number here. N row of HR data 1. And the number that you want to sample out, let's put it like n row, but you want to like 30% of that. Okay, this will be the test index. Okay, that means I will sample from n row, I will sample 30% of them out and then use this as index. Okay, I will run set seed again and run the test index. Now I have the test index. Then I can use this test IND, this test IND to subset the data. Like if I use it to HR data 1 and then put it like this one, minus, then I will get a subset of data, right? This subset of data would be the training set. HR data training. Right. HR data training. Oh, sorry, this is not right. Yeah, I forgot comma. Right, now it is correct. I don't, because when I did not put, if I did not put comma here, then it means that I'm selecting the columns. By putting comma here, it means that I'm selecting the row. Okay, so I'm selecting like this row out. And for testing, right now I have 1,470 observation for training. Oh, no, sorry. Yeah, I did wrong here. Let me run everything again. Yeah, I got here 1,029 observation for training and 441 observation for testing. I use testing, why not test? Okay, done. Now let's move on. Next, we are creating a decision tree, right? You can look at the distribution, exploring the profile, compare the between distribution. This can be done by using summary, HR data training, and we get this distribution. Important things is like this attrition. You can compare between them, right? Attrition is 860. Let me put it 860 to 169. Now, if I use this for the training, for the testing, this proportion would be 373 per 68. Right? You can check if the two data sets that we sample contain similar distribution or not. This is called sanity check. Whether you are sane, whether these are sane or not, whether the sample are sane or not, whether they are okay or not, right? How do we know? You can just calculate the prior probability, 169 divided by 169 plus 860, and this is 16.4% compared to 68 divided by 68 plus 373 is 15 something percent. So about this, they are about equal, so it should be fine, right? So if the values are totally different, then that means the sample data are not good. It'll be better if you have more data set, with more sample size. All right. Now let's move on. So next, we are creating a model, but there's different criteria for splitting. You can see that what I taught you earlier is that in classification, you can use entropy, right? Information gain to guide the way to do that. But using information gain in implementation, in writing code, is not actually a good idea. Can anyone tell me why using information gain in coding is not so good idea? Right? Information gain formula is IG equal entropy of parent minus expected entropy of children. And we know that entropy is P minus P1 log of P1 minus P2 log of P2. Why using information gain coding is not a good idea? There is actually a better way. It's called Gini, right? Gini criteria. What's different? Can you tell me? In coding, what is the problem with entropy? You can get the same thing with a simpler calculation. So you know that the idea of entropy is that if you have mixture, you have high value, right? The problem with entropy is this. This is log. Because it is a log, it needs to be calculated as floating point. Floating point require memories. And if you have very low value, that means this log will be very large value. When it is very large value, then that's the problem. because the minus infinity, you need to get a very large value to cover that. And there's no point to do that if you have a better calculation to do so. So there is a better way to calculate something that is similar to entropy by calculating Gini. This is done by taking just P multiplied by 1 minus P. Okay, now if you look at this value, when will this value be the peak? When will it has the highest value? What value of P would result in highest P times 1 minus P? Right? Answer in the chat. What value should it be? When will P times 1 minus P would have the peak, would be the peak value? What value of P? Anyone? If P is 1, right? Then P times 1 minus P would be 0. If P is 0, then P times 1 minus P would be 0. If P is 0.5, then P times 1 minus P would be 0.25. Right? This is the highest value that it can get. So you can see that by just multiplying, you get something similar to entropy. Okay, so instead of using information gain that use entropy, we can now use this multiplication and then just see the reduction in the values of the Gini criterion, right? Using the same approach, parent minus children, to select the best one. Okay, so this is how it is used in R, in Python, right? But in terms of calculation, I would still defer to the use of entropy. I would still prefer that you guys think in terms of entropy way instead of this one. This one is good in calculation, but in terms of conveying the way that it works, entropy is better. Okay, but now if we look at the proportion and compare Gini to information gain and to the rescale Gini to get something that is similar to information gain, you can see that they are quite similar in terms of the peak. It would be peak at 0.5. That means you can use it to do the job, right? Now let's create decision tree. Okay, switching back to code. Right, you can create decision tree by using library rpart. There are many libraries to do the job. One of which that has been used often is rpart. This is a library to create rpart, to create classification and regression tree, right? Recursive partitioning and regression tree. Okay, creating a model in R is whatever model it is would fall into the same way that to create that. First, you need to something to denote as variable, and the model and the formula. The formula would be the output tilde input. Right, our output would be the column known as attrition. Okay, so I will write here as attrition. ATTRI, attrition. Tilde input. Okay, so for this one, I'll use all columns to create model. So I'll just use dot. All right, and the data would equals to HR data training. Okay, done. This is the tree that I have created. So you can look at the tree by import the library rpart.plot. No library there. Sorry. So probably that is already plot. Yeah, library rpath.plot. But I did not, well, sorry, I forgot to install it. Install packages. Rpath.plot. Yeah. Library rpath.plot. Then I'll use rpath.plot of 3. Right? Then I have this result. Well, look hard. Now it's hard to see here. So yeah, it actually looks like this. And to get it like that, better way would be to use PDF device. Let's say PDF, and the file would be the 3.pdf and def off. This would create a PDF file. A PDF file containing this. Let me switch to the folder. Right. So this is the resulting file. Over time here is the first one. So how to interpret this? In this, you can see that it gives you the tree, right? And interior nodes would contain the interior node would contain variables that you use to perform segmentation. Leaf node contains the segments. Okay, so if we take a look at this one, you can see that in the plot here, it gives you the node. A node here is over time equal no. So that means the first one that is used to test is over time. Over time equal no. If it is yes, go to the left hand side. If it is no, go to the right hand side. So what does it mean? It means that the first variable that is chosen, is over time. And this percentage is the percent of data set. So percent here is the percentage of data point. All right. The probability here is the probability prop of class. For this one is for prop of class yes. Right, probability of class yes. And label here is the let's say the predicted label. The label of segment. Or we can see say that this is predicted label. So if we did not divide anything at all, you can see that the majority of the class is no. That's why this is concluded as no for the highest level. Okay, so each of these has certain meanings. And once we make division, you can see that on the left hand side, if over time equal no is yes. So you need to be careful about interpreting the logic here. Over time equal no is yes, meaning that the left hand side here is over time equal no. While the right hand side is over time equal yes. The color indicate you can see that if it is likely to be yes, it will be green. If it is no, it will be blue, right? So use this to make distinction. You can change it in the code, but whatever, that's later on, right? So be careful about this one. Over time equal no is yes, that means over time equal no, okay? And these are 72%, right, here. 72% of them have overtime equal no, okay? Only 28% have overtime equal yes, all right? So this is how you look at this graph. So after overtime, then it comes to the, for the right hand side here, monthly income is the best variable to segment into class. And then you can see that this is monthly income more than 3,752. Again, left is yes, right is no. That means if you were to annotate this, then the left part here is monthly income more than or equal 3752. This is monthly income less than or less than 3752. All right. So this person work overtime but get low monthly income. That means not the person, these populations. So they are likely, 10% of them are likely to leave the company based on these reasons. Okay. So by looking at the whole tree, you can see the reasons that you can see that the algorithm learn the reasons that people leave these companies. So the first part may be because of this, but you can see that it's not just this. We have this as well. If you look at the age, if age less than more than 31, age more than equal 31, yes, left hand side, no, right hand side. This will be age less than 31. If if the individual have age less than 31, still young, then they are likely to leave the company. If age more than 31, they are likely to stay in the company. Right. So you can see the segmentation of the groups into into subgroups that are likely to have those attributes. And at the end here, you now have the subsegment that have like 90% to leave the company, 75% to leave the company. You also have the group like this 11%, no, sorry, this is 89% likely to leave, but that's only 3% of the total population. But these are like 11% that have like 0.9, 0.09 chance to leave. That means unlikely to leave. Consists of like 11% of the population. All right, so these are the decision tree, right? And then we can use this decision tree to make prediction on which person, which individuals would leave the companies, right? Based on the data set that these are learned. All right. So this is the decision tree that you get from our part. Right. We can see which variable is important by using $3 and variable importance. This would give you the ranked list of the which variable give you more information than the other one. Right, the first one is monthly income, give you more information than the others, and then job role and overtime and job level and so on. So we now know which variable, what should be the likely reasons that the person would stay or not staying at the company. First one, salary, right? The income. Next one, whether this person get the proper role or not. The third one, whether this person work overtime or not, and job level of this person. So you can we can have like the reasons that involving with attrition. That if this company has a lot of attrition, so they might want to change the strategy based on income and the job roles here, right? So you can take a look at variable importance in attrition, and using this variable importance, right? And actually the way that it is done is like this, is when you select like at previous examples, select balance, it creates a type of boundaries that divide the data point into two parts. And once you use more variable like age to make division, you create a type of sub partition, and then so on when you have more variables, create more subpartition. This is just two dimension, age and balance, but you can see that the previous example, we have like 10 something variables. That means those variables form like more than 2 dimensions, which cannot be drawn here, right? We can make prediction by using the this predict. Predict allow you to make prediction based on the model. We have the tree, right? If you type in just tree, this is the model that we have, the whole things. You can use this in prediction, predict using tree, and then the data set that you want to predict, HR data and testing. Right? Use HR data and testing, it will predict each row, right? Each row of the testing data set. And give you this, that is the first one, it has a chance of no equal 0.94, chance of yes equal 0.05. The second one have no equal 0.81, yes equal 0.18. The third one, no equal 0.94, yes equal 0.05. Right? Now we have the probability of the person in testing set to be no or yes. All right. So the next would be to, you can predict it as class, right? You can predict and then say type equal class. Then if you predict to no and yes as a class, right? To no and yes as a class. Let's assign this to rest, the results here. Because now we have less as the factor, no and yes. Now we can compare what? Compare rest with HR data testing, $ attrition. We can compare this attrition and the rest that we have predicted, right? The results of prediction and the actual one, to see whether the model gives you good results or not. Okay, how to do evaluation. I will talk more about this in the I think in the next lecture. That will be the last lecture on model evaluation. Okay, right? I think. Right. It will be model evaluation in the next lecture. And let's wait for, until we finish with this. I'll talk about the term project and the term project and the exam. Right. Once you get that results, you need to form it into this confusion matrix. The confusion matrix is the to determine whether you make correct or incorrect prediction. I think we talked about this already, right? In the logistic regression lecture. True positive would be a correct prediction. True negative is correct prediction, but in a negative class. False positive predict yes, but it's actually not. False negative, missing that. In coronavirus testing, true positive means that you detect that the person would have coronavirus. False positive means that the test say that the person has, but actually doesn't have that. False negative is the test say that the person doesn't have that, but he or she actually has that. True negative means that you say correctly that is this person doesn't have that. And then measurement of the performance of the model can be done through accuracy. Accuracy is to combine positive, the true class, and then divided by the overall. Accuracy is okay if you have 50-50 proportion. You will see that accuracy next lecture. You see that accuracy fall apart if you have skill class. Refer to this. You remember last time we talked about this. Recall is this semicircle, and then proportion divided by the half square here, If this would indicate the completeness, the coverage of the test, whether it would cover a lot of people that have that is relevant to the test. So it would indicate whether a model can filter out, whether the model can cover the people who need to be covered. While precisions indicate the preciseness, the exactness of the model, whether the model is accurate in terms of make prediction in this, like in the circle here, indicate the model, the results that the model predict, and then we get only the part that is correct divided by the overall, we get the precision. F1 is like a combination between the two. Just multiply them, divide them, and then multiply by 2. You get the F measure, right? So this is how you can calculate the accuracy in R, and this is done through the Caret library, right? So need to use Caret. And then from Caret, we can use confusion matrix. And in the confusion matrix, you need to give it with the predicted result first, and then the HR data testing attrition. And you need to also specify the mode. Right? Mode equal precision and recall. And also positive class. Positive equal yes. Right. Here's the result. From what we have there, we have this result. The model can it give you this confusion matrix. That is prediction yes and yes. So prediction yes is correct 50% of the time, and this can cover people about 25%. So the model is not that good, but this you can see that it kind of learned pattern from the data, and it gives you a better precision, right? If compared to a prior probability, that's 15%. That means if you randomly select people out and then determine whether that person would resign or not, would be attritions or not, you get a chance about 15%. But using the model, the chance now improved to 50%, right? So that's about 3-fold from random selection. So it's good, but it can cover only like 25% of the cases, right? So this is the performance of the model. If we use a more complicated model like random forest boosting, you can make this number reach to like 80% for both of them, right? But in our class here in data model, we will stop at this point in terms of the modeling techniques. And then if you want to know more, you can join us in all the classes about the advanced machine learning later on because of the time limitation we have here. Right, so this is a way to do the creating a model from data. You can see that we have gone through multiple models. We have gone through regression model, logistic regression, classification model, using decision tree to perform classification model. In the next lecture, we will take a look at the issues, the important issues about evaluation. That is when you have like this data set, skill class, the class that likely to happen more than another. And also the benefit and cost of making wrong decision and the right decision. Right? We will take a look at that in the next class.